Can you hear us now?
Okay, now I'll repeat myself entirely because the four people remote couldn't hear that at all. Welcome to MOQ, now in 3D as a working group for the first time. This is our first meeting as a working group at a plenary IETF. As you know, we had an interim, but this is our first one. For those of you who are not used to the IETF, by this point in the week, people gather a little bit slowly for the first one. So we're going to give it a couple of minutes, but not too many, because we have a pretty packed agenda. So please find your seats as quickly as you can. Remember, hopefully by this point, that you do need to be wearing a mask if you're not actively eating or drinking. So if you're drinking, go ahead and take your mask off, but then put it right back on. Sure. So you have control. I can just peek over there.
All right. Good morning, everybody. We're going to get started. This is the note well. It's Thursday. I think everyone's read the note well. If you haven't, please do. It contains a lot of important information and guidelines about how we do work here at the IETF. Next slide. Again, it's Thursday. I think most people have figured it out, but if you're here, make sure you're. Can I turn it up? I'll just get nice and close. Hello. Thank you. All right, if you're in person, use the little Meet Echo client to get yourself into the queue and make sure you're wearing your mask unless you're speaking, as Ted has said. And remote participants, make sure your AV is off unless you're presenting or talking, and use headset, etc. Thanks. If you need any general information about London, agenda, etc., you can find it here. Our agenda is here. I'm Alan. This is Ted. Gory has volunteered to take notes. Luke is backing him up. If anybody else wants to jump in the note stock and help them out, I'm sure they'd appreciate it. Is there somebody who will relay comments from Zulip? It's okay. I think the chairs can probably also keep an eye for that. Okay, so what are we going to talk about? Administrivia and agenda bashing. We're going to give a report from our interim, which was just last month. I think some people might have missed it because it happened so quickly. So we'll just talk about some of the decisions we made there. Then Luke's going to give a presentation on the combined proposal from the authors of Rush, Warp, and Quickr. And we'll spend some time discussing that. Colin is going to talk about relays and how they work, and we'll have I'm sure, healthy discussion about that. And then we'll talk about possibly having an interim in January before Yokohama. Does anybody want to bash the agenda? Okay. You may have seen this note on the list. Zahed has been appointed as a mock technical advisor. So if you need technical advice, fund Zahed. Okay. Things that we talked about at the interim. We're going to use GitHub to manage our documents, as all the cool kids do. And we're going to use issues mostly to track and PRs for changes. Please try to keep discussion off the PRs and just into the issues, and also on the list, of course. Some folks were concerned about the way retention works for Slack, so we're in the process of setting up some kind of bridge for Slack so that we will have a means to retain the messages. But until that time, please don't conduct working group discussions over Slack. Stay tuned on the list for more updates there. And we talked about what we're going to put on this agenda, and we are here. And you had your chance to bash the agenda. So moving on. So, all right, with that, we'll bring up Luke to talk about the combined proposal.
Oops. You need to, yeah, right there. Oh, I need to request again, I guess. Looks good. Hello, media real quick. Good morning. I've got a lot of slides. This is going to be quick, but let's start going. I'm Luke. I work at Twitch, and I've been working on the combined Rush and Warp and QuickR draft, just to try to find base common ground between them. So before we begin, there's probably a lot of quick enthusiasts in the crowd. Maybe not so many media enthusiasts, so I really wanted to cover some basics. Starting off, just media encoding. It can get complicated, but at a really simple level, you have iframes that are effectively just static images. And then as time goes, you can have p frames that will reference one or more frames in the past. So this is delta encoding. The idea is there's too many bits if you try to encode every image separately. And every so often, you'll see we'll reset the chain and make a new iframe. But this is a kind of common encoding, actually. This is really simple, but it's low latency, and you see this a lot with like WebRTC and conferencing. We can have more complicated encoding. This is one possible example. We have B frames. They're annoying because they can reference future frames as well. This has a lot of ramifications in how you write these frames to the wire. But in this example, we have some B frames that will reference the I's and the P's, but themselves are not referenced. You see this more common from like hardware encoders that have a very fixed structure. But the benefit of stuff like B frames and more references in general is that you can enhance the compression ratio. You can effectively, more references you use, the less bits you need to encode typically. And then finally, you can get some just really gnarly encodings, especially if you let a software encoder and give it like a few hours. It will produce the most jumbled mess, the most complicated possible encoding of every frame referencing every other frame, more just creating a tangled web of dependencies. And it's really hard to know how you're supposed to send this over the network, but we try. One nice property worth mentioning is that when there's a new iframe, you typically have what are called closed GOPs, where you do not reference the previous group of pictures. So that's a nice property. You cannot have a dependency go across this line. So we abuse that, and a lot of protocols abuse that. So we're making a live media protocol, a live media transport, and there's a few high-level goals that I've been really trying to adhere to. So number one, make sure you respect the encoding over the network. So the idea being is we want to send media as it needs to be decoded and as it is encoded. We don't want to try to do our own delivery mechanism. We want to make sure that if this frame depends on this frame, then over the network, this frame also depends on this frame. I've been mostly focusing on number two, minimizing latency during congestion. I've been trying to improve our live video system to try and reduce latency. But the idea being is that when networks suffer, you need to have a plan to decide how to keep latency low. And number three, of course, use Quick. It's in the working group name after all, but funnily enough, we've discovered Quick later in the process, and it just kind of had all these natural properties. We did not set out to use Quick initially. But yeah, it's in the charter. So some more little history. We have this existing, this kind of annoying GOP structure with B frames. How do you serialize this over TCP? How do you make like RTMP, HLS dash, how do they work? And more or less they take this structure and they put it into one big chain. The idea being is you make sure that all dependencies are first in the chain, and this is what's called decode order. It screws a little bit with timestamps if you see at the very bottom because of B-frames. Don't worry too much about that, but this is one of the reasons why B-frames add latency. And effectively, we just have a long, continuous string of frames. This is nice and easy. This is why like RTMP sees a lot of use still today, is because you just have this chain, send it over the network, it arrives on the other end, and you can decode it. The problem, though, is congestion. What do we do when there's congestion? Let's say we can hypothetically only send half the frames, which is simplifying a little bit because frames have different sizes, but let's say we can only send half of them. What do we do? Well, the solution really is the congestion controller will come in, Reno, Cubic, BBR, whatever, and pick a point in the TCP stream. It will send everything before this point, and everything afterwards it will just queue. And as new frames arrive, we just append them, write them to the TCP socket. They get added to the end of the queue. And this continues and continues where new frames are put in further deeper and deeper into a queue. There's some ways you can get around this. There's some workarounds. Like you can avoid flushing frames to the TCP socket until the last possible minute. And you can do stuff like ABR with HLS dash, but more or less you have headline blocking. And this is one of the, it's very similar to HTTP in terms of the analogies here, where we're introducing a lot of dependencies that shouldn't actually exist. A lot of these new frames, these B's and the P's, don't necessarily depend on any of the previous frames that have been written to TCP, but we make them dependencies over the network. So rule one, these aren't hard and fast rules, but typically a goal one I would say is don't introduce dependencies over the network. The idea being is we should keep the media dependencies, like this frame depends on this frame, and at a transport level, we should not introduce new dependencies just because it's easier. Because otherwise we just add latency during congestion. It's an oversimplification, but as are these slides. So how does RTP solve this? The idea being is, hey, we can't use TCP. Let's break frames into individual packets at MTU boundaries. So we take our existing frames and we slice them up and transmit them ourselves. So the idea is that we do fragmentation, congestion control, reassembly, everything in user space all by ourselves, but we get away from TCP by doing that. And now with congestion, what do we do? What do we do when we can only send half the frames? Well, the idea being is because we do transmissions ourselves, we can choose which packets and more importantly, which frames to transmit. So we selectively decide which packets to transmit and retransmit such that we try to avoid sending like the B frames in this example. They're spurious. They're leaf nodes effectively on our graph. And we try to make sure that there's dependencies. So we really make sure we send the newest iframe. That's the most important thing. And we'll spend extra time retransmitting that or using FEC or whatever to make sure it gets there. So in the best case, we've got 4 frames that arrived on the other end. Unfortunately, there's also a worst case where if you're not intelligent, or let's say you don't have congestion control that's rapid and you just like fire hose the network with all your packets and they just drop randomly, you get this case where you get parts of frames arrive or you don't deliver frames based on dependencies. Like we lost a packet for our iframe and that just causes decode failures going forward. So we lost the same number of packets in this example, but we only decoded the first frame and everything else was lost. So it's very important when you're doing RTP to make sure that you have a very clear understanding of the media encoding, the dependencies, and how the packets are all related to each other. But rule number 2, just to simplify, is don't drop partial frames. Technically slices, but you need to deliver, if a frame is split over multiple packets, they should all be delivered or none of them should be delivered ideally. You don't want to waste bandwidth delivering partial frames. They're not decodable for the most part. So how does Rush solve this? So this is what Meta's been using for like 4 or 5 years now, apparently, you split the media into quick streams. So every frame is a separate quick stream. And the idea being here is like quick, make sure that all the frame is fragmented and transmitted and arrives at the other side in order. So frames can arrive out of order in relation to each other, but within a frame, it will arrive reliably. So same thing. What do we do here? And I should note as well is Quick handles just, again, all the networking stuff. You don't have to do a whole lot in user space. You just have to split the media into frames. It's a lot simpler. But what do we do? What do we do when there's congestion? We can only drop half the frames. Well, just like R2P, there's a similar best case where we call reset stream. We effectively say, I want to drop this frame, or we don't even make a stream for it in the first place. Very, very similar to RTP use case where you can pick and choose which frames you should drop. Although if you don't make the right decisions, in this case we dropped 2 frames only, but we've dropped the worst ones or some really bad ones, and you cause decode errors again. Like if you drop this iframe, a great example, nothing after it in that GOP is decodable without causing artifacts all over the place. So one of the things that Rush does and QuickR does is we put the dependencies on the wire. The idea being is that the sender already knows the dependencies, but relays also know the dependencies, so they can make these intelligent dropping decisions. And this is foreshadowing a little bit to Cullen's presentation, so I won't cover it too much. So rule 3, don't drop dependencies. In graph theory terms, drop the leaf nodes first. You don't want to drop the root of the graph because it just causes everything else to be lost as well. There is a caveat there. A lot of these leaf nodes aren't that big in terms of file size. Like B frames really don't contribute much of the bit rate, but they're still the best to drop first. So why am I here? Why am I standing up here? It's because I've been working on something else for like 3 years now, something called Warp. The idea being here is it's closer to actually TCP, where we just have things in decode order, but we make a quick stream per GOP. So the dash line's missing for some reason, but every iframe, effectively, we make a brand new quick stream. And what we do is we mark them with a delivery order, a little bit of metadata that says that this stream should be delivered before this stream, or this GOP/segment should be delivered before this segment. So I color coded them here, but in this case, the green on the right, these are the newest frames, and these are delivery order 1. I want to deliver these first because we're live. We care about new frames first. Older frames are less important. It's a heuristic, but generally that's what users prefer. So what do? There's congestion. We can only deliver half these frames. Again, same congestion control like as a lot of the other examples. We learn that there's issues on the network. We need to figure out what to drop. And the way that Warp works is we deliver based on this order. So we actually kind of reshuffle the order we send packets. So we send the newest packets first. In this case, the iframe. The packet 5 is sent first, or frame 5 is sent first. And then we'll do the P and then the B. So we've delivered the newest frames first. And then with the remaining congestion window, we will actually go back and try to send the original iframe, frame 0. But it's a requirement for all the frames that follow it. The idea being is that the congestion controller, in my case, I'm just using BBR, just tells you what it can send. These are the packets I can send right now. And we go in descending order and send the streams until eventually we hit the bottleneck, which is we just can't send anymore. And as new frames are generated, so there's a new and a PB frame, these are appended to the newest stream, which is delivery order 1. And what's really cool is these kind of jump the queue. Like in a TCP world, these are added to the very end. In this prioritized world or this delivery order, these some of the frames might get sent. Like the P frame is now in the congestion window, it gets sent. Whereas the B frame is falling on the other end, we will starve that, and we will starve the older frames as well. These frames just sitting in RAM. These are quick streams, so there's 2 quick streams in this example. The yellow quick stream sitting in RAM, using a tiny bit of flow control like max streams, but it's not using anything over the network. It's not competing with other packets. And eventually what you can do is you can just reset the stream. It's not required, but at some point it's gonna be, after like some number of seconds, you're gonna be like, hey, you're just not gonna get sent anytime soon, so we should just free up this memory and stop worrying about having this, you don't wanna have an indefinite chain of frames that need to be sent from like minutes and hours ago, just sitting in RAM. So this is optional, I'll mention, and I'll explain why. Because one of the things that Warp, I really hope it, what I claim it does, is it offers variable latency and relay support. The idea being that the receiver can choose how much latency they want, the latency versus quality trade-off. And this works across relays, which I think is really cool. So just to kind of visualize this, it's a hard concept, so I've done my best to try and visualize this. But we've got a playback session. Right now we've got two frames in the receive buffer, 2 video frames, and a little bit of audio. I should note in this example, audio is slightly prioritized over than video, but that's up to you. In our case, audio is more important. We had the live playhead, that dashed line. That's what the encoder is spitting out, and this is the earliest we could possibly receive a frame over the network. You can think of it like min RTT. And then we have these other playheads on the left. The idea being is that the receiver, in our case, the video player, chooses when they want to start playback, and they choose the size of the jitter buffer to get into networking terms. So as we continue, we generated a little bit more audio, and we delivered some of that audio over the network. The encoder also generated frame 3 of video, but there's a little bit of congestion. It hasn't arrived yet. But either way, we started with this low latency playhead for real-time conferencing. In this example, it's got 2 frames of latency, which is a little absurd, but it's just an example. The idea being is it starts playing out of the jitter buffer almost immediately. So as we continue, we've got some more congestion, actually. We're not seeing frame 4 should have been delivered at this point. And we don't even have audio for that equivalent of frame 4. So at this point, the low latency playhead is already running into a situation where it doesn't have any video to display, and it's just going to show the previous frame. Next slide. And we have a new kid in the block, interactive latency. Interactive versus real time, it's a debatable. I say interactive latency being just higher latency. It's like Twitch style latency, I would call it. But there's some debate over what the best name for that latency range is. But anyway, they start watching video. They've started. And our low latency, our real-time conferencing latency is just running out of the audio buffer. It's going to start just having silence very soon. We still have a massive congestion. None of the new frames have been generated or delivered. Sorry, they haven't been delivered. They have been generated, but they're sitting blocked based on congestion control. But the important thing is because we prioritize, or because we have this delivery order, frame 5 and the little bit of audio that corresponds to it was delivered just in time. It's an iframe, so we're allowed to deliver it, whereas all the previous frames we weren't allowed to skip. They were Ps. But just in time for our real-time latency user to get a little bit of something, as our medium latency viewer catches up and they're about to hit a gap of missing video. We add one more viewer to the mix. This is, I'm just calling it non-interactive latency. This is somebody with maybe a poor network. Maybe it's somebody in Brazil on their mobile phone. You know, like they cannot sustain the latencies that the other users need, or they don't want it. Maybe they're just on the couch or something. Like there's no reason to have low latency. They're just trying to watch football. So they join the picture too. And we're recovering a bit from congestion. On the right side, you see that we've delivered frame 6. We've delivered some audio. We're catching up. There's still a big gaping gap in the middle, which is where the medium latency is. So that user right now they're listening to audio. You see the audio is continuous. They hear it, but their video is frozen or stuttering, much like a conference call. If you've ever everybody's used a conference call at this point, where that's what the user experience is like. And then finally, we keep going forward. We get some more frames popping into the picture. We've now caught up to the live playhead. Everything's been delivered. And we can go back and we can start backfilling the gaps in the buffer. So we've delivered frame 3 and just in time for the high latency user to get it, even though the medium and low latency viewer did not get it. And then we deliver frame 4. So we finally managed to save the day. We patched all the holes in the gap. Just in time for that viewer didn't see any issues at all. And then there's a fourth one I added. This is a archive worker. It could be like 30 seconds delayed. The idea is that it's sitting there. It will just scoop up all the frames eventually and then upload them to storage for a flawless VOD. So for the same stream, you could have somebody with real-time latency that gets a lot of lost frames. And you have the other spectrum, no loss at all, but just high latency. So just to recap, this is the exact same delivery, exact same network conditions, exact same packets being sent over the network, But what decided the user experience is how big the jitter buffer was, more or less. But because we have this delivery order, we can have these different user experiences. So the real-time latency user had the lowest latency, but they dropped video and a little bit of audio, which is usually required if you're doing real-time conferencing, but it's not ideal. I would say in higher latency situations, like a medium latency, they just dropped a little bit of video, but audio is flawless. That's what we're looking for from Twitch, for example. Like users don't need real-time. They prefer to hear the broadcaster, the streamer, even though they might miss a little bit of video. And then a high latency where they just didn't see any issues at all. They didn't even know there was congestion. Maybe ABR kicked in at some point and they would notice that, but in terms of frame losses and frame drops, they didn't notice anything. And then finally, the archive worker. It's just whatever latency you want. You could wait as long as you want while RAM persists, pretty much. Until the streams are eventually reset. Either side could reset. Like the sender could send a reset stream, and the receiver could send a stop sending to say, like, please just don't send me anymore. I've already skipped over this content. That's mostly just to save bandwidth, though. So anyway, with all that in play, we've got this combined draft I've been working on. We're trying to combine warp, rush, and a little bit of quick R. The main concept is any number of frames per stream is a segment. There's a lot of bike shedding on this name, so don't get too attached to it. And the delivery order and dependencies are written on the wire. Again, this is to support relays. The idea is that these dropping decisions can be the same no matter where the congestion occurs. If the congestion occurs on the first hop versus the last hop, should be the same experience. So here's our example encoding again. There's many ways you could break this into segments. So you could do warp, which is effectively you just break it into GOPs, very easy. This is backwards compatible with HLS and Dash, more or less. You just take the same segments and send them over quick. You can fragment a little bit more. You can say, what if we send reference frames and non-reference frames as separate segments, as separate quick streams? We have a little marker at the front that says here's the delivery order, and a little marker that says here are the dependencies between streams. But yeah, we could break it further, because in this case, we have these B frames at the top depend on each other, even though on the actual encoding, they don't. You could break them into individual segments too. You can break it down as far as you want. In this case, we've got a segment for an individual frame. So it's not fate sharing with the other frames when it doesn't need to be. And then finally, you could just break it every frame into its own segment. This is effectively rush. The numbers here, like the delivery order, 1, 2, 3, 4, 5, all the way up, those are arbitrary. It's based on your application and use case. In this case, we want to deliver the newer frames first, but there's certainly use cases where we want to deliver the older frames first. In our case, like for example, you're serving an ad. You don't want to skip any of the ad video. So you kind of flip it around. You turn on the head of line blocking and say that actually the first iframe, which is delivery order 4, make it delivery order 1. Make that the first one we deliver. So there's no skipping allowed. So there's a lot of business logic. We'll kind of talk about this at some point in the future about delivery order. There's no right answer, effectively, to how you prioritize frames. Somebody has to decide which frames are more important. Somebody has to decide it's audio more important. Somebody has to decide even like which renditions and whatnot are important. So what's next? I forgot to draw a bike, but this is a shed. The names are really hard. So we're not sure if we should call this warp or rush or media quick or some made up name. And especially the name of segments. Like, are these segments? Are they layers? Are they fragments, chunks, media quick, prefix things, foo bars? Like every word, every name we've looked at has like existing connotations that it clashes with. And then I've been working on this draft mostly. There's a GitHub repo, Kixelated Warp Draft. I found a lot of issues, but there's a lot of core things missing, like a wire format. I've defined how media should be sent, but we don't even have a way of how the bytes should be written to streams yet. We're also trying to figure out how CDN support works. Right now, the protocol is push-based. It's very simple. Web transport, you push. But we want to figure out what's the middle ground we can find to make sure that existing CDNs that are all HTTP based and pull can still work with this protocol. So it doesn't really matter if it's push versus pull, so long as you send media the same way over quick streams. But we want to ideally have one protocol for both contribution and distribution. And we need to figure out where the middle ground is there. And just all the media stuff, like how do you send tracks? How do you choose tracks? How do you do, which codecs, which container even? The current draft has like CMAF, but we still haven't even decided. So everything that's actually required to make sure media playback works is currently missing. Just the networking stuff is what I've been focusing on. I've also been working on a demo, quick.video/demo. I will say it's very crude. It's just hosted on a single host tiny instance in US West 2. I'm working on it too, but there's code also on GitHub to show how this works and some examples. And then finally with adoption, I don't know the process. I don't think this is ready for adoption yet, but I really want to get the idea from the room. Is this the right direction? How do we feel? What do we think is missing? What do we think should be laid out first? A lot of contributors. So I'm Luke, again, representing the Twitch folks. Most of them are online. And then from Cisco, we've got Suhas Cullen and Meta, Kirill, Allen, and Jordy have been helping a lot with this draft, along others. I've seen there's a few folks have left a lot of issues lately too. And that's all I got.
Speaking of contributors, the queue is quite full at this point. Sam, you're up first.
Good morning. Sam Hurst, BBC R&D. Thanks very much for the presentation. That was really cool. And kudos on the handwritten slides. I love that. So I have a question about the delivery order number that you were showing up there. Is that just a constantly incrementing number as it goes through, or is that a more sort of dynamic value that changes depending on one particular instance in time?
Yeah, so we still need to work out if this is right now it's one continuous number space. It's just a uint64. How Warp works in production for how I've coded it is it's effectively just the presentation timestamp plus 3 seconds if it's audio, just to give audio a little bit of a head start. But effectively, it's an arbitrary number, so long as the lower number is delivered first. Or in my case, I'm doing the presentation timestamp. But anyway, it's arbitrary.
Okay, thank you.
Mo?
Zanatiak, great overview. Gross oversimplification, like you said, but I think it's the right oversimplification for transport folks. One important aspect that I'm not sure was conveyed, which I think it matters a lot for the transport folks to understand, is that there's differences between congestion control and rate control, and even within congestion control, there's also, when you talk about prioritization, there's different concepts of the prioritization about whether you're talking about your local queues or whether you're talking about marking things properly so that the network queues handle your congestion the way that you intended. So first, I think we want to make sure that people understand that over long time windows, we're not using congestion control to instantaneously decide which packets are sent. That the congestion controller's overall average bandwidth estimate gets fed up slowly to the app, and that changes the media encoding rate. So you're not just going to drop individual parts of your stream. You're going to select a totally different stream encoding in order to meet the budget that your congestion controller is telling you over a long time. That's not useful for an instantaneous decision that the congestion control says, you know what, I know I'm not going to send this packet because I don't have a window open to send this packet. So that's where an immediate priority can help on a marking from the app layer to the quick layer. It can drop something immediately or hold something back immediately. But the longer time windows, those are going to be controlled by rate controller feedback to change the media encoding itself. So I think it's important to keep those things in mind. And also the difference between congestion control decisions to do something for internal queues versus how they get marked for network queues. Because, wireless, WMM and mobile wireless QCIs and wired DSCPs and things like that, there should be different ways to map the application level priorities to those network priorities. And I think it's important to get that right in these drafts as well.
Yeah, one thing I didn't mention, and you rightly pointed out, is that these don't have to be the same bitrate. Like these segments, the encoder, as it sees congestion, can start decreasing the bitrate in response. This is meant to be a response when you can't change the encoder in time, especially for contribution. Like you have to switch renditions at iframe boundaries. Um, but yeah, and prioritization is only as effective as how quickly you can detect congestion. If you have something like buffer bloat, everything's over the network unprioritized. So giving more information to the network layer helps as well.
And I think this order that you have, I think it came across in the presentation as this is something baked into the protocol, but that's an application level thing that it can choose to decide whatever delivery priority it wants for things, because for some people the user experience may be terrible. If it's stuttering, that order that you showed before would be under congestion. Your video is constantly stuttering, right? You cancel something that's being played right now and you try to play the live edge, and so you get someone always for half a second of the live edge instead of a full second of continuous video. So I think that user experience is up to the app to figure out what the right order and priorities should be, not something baked into the protocol.
Thanks for that. I will notice that some of the discussion that's currently happening on the chat has touched on ABR and other things like that. So if you're watching this on YouTube, please do go seek out the chat stream as well, which should be linked from the IETF site, because there's certainly some working group discussion happening in that. Function.
Han from Huawei. And I see it's a combined protocol from 3 drafts, but there is a lot of things in QuickR is missing here. I think the pub-sub relationship and use quick datagram. As for the pub-sub, I think maybe it can bring a lot of state in the relay. I think that's why you drop it.
Yeah, this is meant to be a base draft, as in we take everything combined, and the idea is something like QuickR could either be added on top of this draft or just a separate draft entirely. We're not sure yet. This is meant to be the common ground.
Yeah, I can see the pub-sub being implemented over this draft.
Yep.
Maybe another layer, but the quick datagram thing, do you think you need to in the base draft?
So I think in quick streams are more than capable of doing even real-time latency. So long as, again, you have some way of deciding which quick streams to send first and which fragments to send first. So I don't think datagrams are necessary, which is a controversial statement. But yeah, by having more tight control over what the quick library sends, end of the day, it's the same media getting fragmented. The difference is if you do it in the application layer or if Quick does it, so long as you can tell the Quick library to fragment in such a way, it's the same thing.
Yeah, I think RTP is kind of like the quick datagram instead of the stream, right? So the benefit by using the datagram is that you can prepend some metadata to each datagram. So you can drop it in more fine-grained way. Okay.
Yeah, possibly.
Piers?
I guess the assumption, hi, Piers O'Hanlon on BBC R&D, is the assumption here is sort of traditional kind of representation, kind of breakdown of the video, as opposed to like SVC type kind of. So then, if we're thinking that, then it's then, is there an ABR stage, or is this really the ABR? Because I guess that's happening in WebRTC already with the SFU approach, where you just pull things out. I sort of wondered you thought about that, because it's just sort of seems to be quite sort of low level IPB based, but.
So first off, I'm doing ABR we're using this approach. The idea being is that the sender chooses which of these segments to send. So based on the congestion window, it can switch down a rendition. You did mention SVC. I'll very quickly switch to just in case somebody asks. This is an example. Don't overthink this, but the idea is you could have a base layer like 360p, and then you can have segments that build on top of it. So SVC, if people don't know, you have a base layer, 360p in this case, and you can have enhancement layers on top. So we're pretty much just sending SVC layers as quick streams, is more or less this proposal. But I don't know enough about SVC. This is just like an idea.
Right. Okay. Yeah, I thought it seemed like it would naturally extend to it in a way, but then in another sense, it would then maybe uh, you wouldn't necessarily need this would become the kind of ABR
Possibly.
aspect.
Although I don't think we want to require SVC.
Right. And the prioritization thing, so that would be happening kind of in a potentially some kind of switch relay entity or some kind of quick relay kind of entity where so then I guess there was a previous one about how that maps down to the actual network priorities.
We're going to cover that a good bit in the next.
Okay.
So if you can hold that for the next.
Fine. Okay. Thanks.
And just the chairs are about to lock the queue. So if you feel like you want to be following up on this, please get in the queue now. Christian.
Nice presentation, Luke. I mean, I like the simplification. It makes the thing easy to understand. One thing that is missed in the simplification is the effect of this segmentation on relays. Because if you have a set of streams, as you describe, then you are going to get head-of-line blocking on these streams. And if you have a series of relays, then you are going to get head-of-line of blocking at each of the relay, and the delays induced by head-of-line blocking will combine. And that's the reason why I had been exploring how to do the same kind of architecture with datagrams, so that effectively when you have relays, you get fraction of the streams in the datagrams, and you can decide to forward them immediately, thus avoiding the head-of-line blocking.
Yeah, I'll let Cullen cover that more, but just really simple response. That assumes that you're reading streams in order and then writing them in order, but you can get around that if you can read and write out of order to quick streams, beholden to flow control. So that's
yeah. I understand what you said there, but that's extremely hard to do because the reading in. I mean, basically, if you're doing datagrams, the application being in control can do whatever. If you are doing streams, the application is not in control, and this business of reading stream out of order is really, really hard.
I would say this is a general problem for quick relays. Like even HTTP suffers from this, where a gap for packet loss will cause blocking. But yeah, for sure.
Victor?
Victor Vasiliev, Google. I just wanted quickly to say that I support this proposal. I'm not sure it's in a stage for adoption, but whatever there is that's not a to-do looks very good. And thank you very much for working this.
Suhas from Cisco. Thanks, Luke. I know. Okay, is it better now? Cool. So thanks, Luke, for the presentation and trying to kind of combine things, good things from all the protocols. And I agree, this is a good start, and we have quite a bit of things to cover to make it more usable, especially thinking end-to-end protocol, not just the transport, but also the relays and consumption side. How do you ask for things? They all depend on how do you break the things to start with, so that we can define the end-to-end protocol. I think we need to get some of those pieces in. And I want to kind of talk on a couple of things that was raised, more on someone else, on the delivery and the priority. I think there are two different concepts. Like priority is more like saying how is one thing important in relative to other, and delivery order is more like how my decoder wants to get it in so that it can do some good work. And probably we need to kind of spend some more time on thinking how relays would understand the data, but not baking too much in protocol, but leaving it to the application space to define how it is done. That would be helpful. And another point on the datagrams, I agree. At some point, as a group, we have to kind of make a decision on how do we meet the use cases that we have MOQ chartered for. HTTP does not have to do real time, so hence it's okay, but MOQ is not constrained by that. We have more use cases, and we might not do datagram. It's a working group decision at some point, but we need to say, can whatever protocol we develop in whatever transport we do works for the use cases? Thanks.
Peter Thutter?
My audio working?
Yes.
Okay. First, I'd like to say I think it's good that you're building on web transport. That solves a lot of like multiplexing issues. And it allows for, I think you should allow for either streams or datagrams. I think streams are fine to use, but I think it makes sense to allow the client to do either. And that's, I believe, the direction RTP over Quick is doing. During your presentation, you mentioned that you haven't defined at all the media protocol. Are you looking for contributions on that front? I have ideas that I'd be happy to contribute.
Yep, of course. If anybody wants to help, either on the protocol or on the demo, or just want to talk to me, go for it. Looking for contributions.
Okay, great. Thanks. That's it.
Randall? Randall, we can't hear you yet.
That I think will do it. There we go. Can you hear me now?
Yes.
Okay. I notice you have the SVC example here. For the case where you're not using SVC, but you're just feeding multiple different resolutions or bit rates up, I'd be interested in see how that maps here. But also, I notice also that all the playheads you've defined in your other diagram appear to be at the same location. As in, all these things are arriving at that location, and you have different playheads which appear to be running off the same buffer stream, whatever. Okay, is that actually what's anticipated here? Which would seem odd, except for maybe like the recording stream, recording head, or is there something more complex going on here? As in, like, is this actually getting fed out to different locations, which I imagine it is, which may be consuming different portions of a multi-layered, multi-bit rate stream?
Okay, sure. So first off, for simulcast, which is sending multiple renditions that don't depend on each other, it's effectively this SVC example. You just remove those arrows between layers. So in this case, you'd send the 360p rendition. It's got the highest priority, it'll be delivered first, and then any extra bandwidth will be sent on higher quality ones. So sending multiple renditions works very similar to SVC. There's just no dependencies between segments and layers. And then finally, for the playhead, you would not be receiving those all. That's just just a visualization. The idea is that different viewers will have different network conditions, so they all have different starvation, congestion. I just wanted to explain that even with the same network situation, you could have different experiences based on the size of that jitter buffer. And the size of that jitter buffer depends on the use case, the desired user experience, but everybody would get a different experience.
Yeah, I think it would be more illustrative and more better for discussion if we use a slightly more real world case for that, because that affects some of these questions and answers about how to do this. Thank you.
Thank you, Randall. And I think that brings us to the kind of next steps question here. The discussion has been great today. We definitely kicked off a lot of different issues, both at the mic line, and again, I'll point out during the chat, almost a distinct set of issues was gone through. And Luke, I encourage you to go through the chat, and anybody who's watching us post facto to do the same. We're definitely not going to do a call for adoption today. It's pretty clear there's a lot of stuff that people need to hash out first. But please do keep the discussion going on the list, even though we will be talking about an interim later on in this meeting. We really want to make sure that we don't have to have the pace of discussion only at these meetings. There's definitely a lot of this that you can do in either mailing list discussion or on the issues for the GitHub repo. So thanks very much. Our next thing on the agenda is a different presentation. Colin, you want to come up? And by the way, if you have not actually signed in to the tool because you weren't thinking you were going to get up or something like that, we'd really appreciate you doing so, because this is a pretty tight fit for a room, and we'd love to have a little bit more spacious space when we get to Yokohama. So.
Whoa, forgot I had to stand in the pink square here. Okay, awesome. Thank you. Test, that working? Okay. When I step away from the mic, abuse me. So I'm going to talk a little bit about the relay stuff here, and whoa, huge lag. The goals of this discussion is really around understanding some of the commonality of some of the questions that come up in every one of the relay drafts that we've had. A lot of these drafts had relays or things that are a lot like them in some way. So I want to try and hit some of the similarities, differences. There's lots of more nuanced things that even some of them came up in the previous conversation, which unfortunately I don't really talk about at all in here. But I think we're just, it's a first working group meeting. We're trying to figure out what are the big things and get them moving along and get us all sort of talking on the same page and having a good discussion about things that need to be. I was really thankful that I love the last discussion. Lots of good ideas came up, and it wasn't about like, oh, it's A versus B. It was like, oh, this is a property that we need in the end system we're going to do, and that's a great way to think about stuff at this stage of a working group. So, where do relays fit in here? And in every one of these systems that we're talking about on the ingest side, our producers are creating some content, they're pushing it over some protocol up to something. You can call it a server, you can call it a relay, you can call it a CDN, but it's going up to something. We're going to talk a little bit more of that in a second. And on the other side, something up probably in the cloud. And again, it may be a CDN, it may be a relay, it may be however you think about it, an SFU, these types of things are bringing the data down to the consumers. And the key point here is we're not trying to define and figure out exactly how that CDN relay internals works. What we're trying to make sure is that the protocol we're defining here, which is going from the A to the X's, or from the Y's down to the C's, has enough information in it that the X and the Y devices, whatever they are, have the information that they need to achieve the end-to-end user experience that we want to achieve here. Okay. So there's some things in there that you end up having to know. If consumer C has twice the bandwidth as consumer D and producer A is making things in different resolutions or whatever, there's some information you need to know in here that helps works. And it's not much information. We're going to get to that later. Now, the other things is we talk about the security on this stuff. So I wanted to just sort of hit a little bit of the terminology in here on this slide. There's not. I'm defining, just by definition, that the ends are the producers and the consumers, things that have the ability to encode or decode the video, decrypt it, can see the media, those types of things. The relays in the middle here are not ends, they're middles. So they cannot do things like that. And when we start talking about the ability in our charter, we have a strong requirement for end-to-end security. We're talking about the producers and the consumers being able to do it. If there was a transcoder in the middle of this network, it has to access the media, obviously, and which means it's an end. And a transcoder is probably both a producer and a consumer of different streams, and is in the end. You know what? I think my audio is really messed up. I'm going to take my mask off for a second. Okay, so that's what I mean by ends and such. Next slide, maybe. Back a slide, maybe. Okay. So we do get the question of like, well, do we have these? Who's going to provide these relays? And it was one of the questions that was raised a lot in the beginning. Will anyone build this type of stuff? And so there will probably be a range of different people that do it. There's some companies that have a CDN or something like it today. Twitch is an example of this, right? They have this, they operate it themselves, they can deal with this stuff. They want to probably use some of the existing things they have and don't disrupt without them. There's companies like that, WebEx, part of Cisco, that today does its own media nodes near the edge and pushing them out to all of these places, but would rather run that on somebody else's infrastructure and buy that. And there's companies like Akamai, Cloudflare, Fastly have all talked to me about MOQ in various forms and those types of things. There's companies like InterDigital that has drafts here that are looking at relays that are tightly tied to 5G network optimization so they could provide a better experience for the media than you could if you weren't. So that there's a range of those types of issues. So do I have a queue built up here? Warn me if I do, because I will stop if we need questions. So what really drives the need for these relays? Why do all these existing networks have them? Well, there's a bunch of different reasons. Some of the sort of the two biggest ones for me are, one is on the distribution side, you need fan out. You need some device that can, take your content, instead of just going to one person, spread it out to hundreds of people or millions of people and scale that up. And these are a convenient way to do that type of thing. And the closer you move that, you can have some bandwidth savings and some of those types of other issues as well. Then there's another point of you're trying to get these relays closer to the consumers or the producers. So let's talk about in the consumer case for a second. The closer it is, the less round trip there is between the device consuming it and the device that has a valid copy of the media you're trying to receive. And the more you can squeeze the time, that it takes to get a message back and forth between those, the more you can use quick streams and things like that to retransmit data you lost and still not have it slide out and still not have it extend the latency of your overall delivery of the media from a glass-to-glass point of view. So this is why you see so many like any of the major media networks today, just even doing dash or HLS or something like that. I mean, you don't try and deliver video to users in Australia by using a CDN server in London. That's just not a very effective way to do it. You try and get it close to there so that when there's loss on a local LAN link, it's a much faster place that you can say, I lost this packet, please return it and get it back to me. So bringing those things up. Now, some people, like the 5G people, want to extend that much farther and closer out to the edge than we've traditionally seen in today's networks. And that's one of the things that's changing that allows more bandwidth. So that's some of the things we're trying to hit here and why we have these relays at all. So these operational requirements, a few of these comes out. You want to minimize load and make them easy to scale, normal sort of things in trying to develop any cloud server. You need to make them configurable, but fundamentally they're making decisions about what to forward, what to drop. Okay, that's really what they do. They take some packets in, they send some packets out, and you decide which one of those go in and out. A lot of the requirements drafts, we saw some sort of requirement to clearly hand off a client to a new relay to reschedule relays or reload balance, take something out of service. And this is the sort of go away messages that you see in several of the protocols. So this sort of relay redirect type idea. Low latencies, obviously the whole point of this sort of thing. And rapid recovery from failed things. These are all requirements that we're going to have to figure out how our protocol will help, what our protocol needs to be able to support those operational requirements. Again, I'm just defining this as terminology by definition, not some logical sort of thing. I'm splitting the stuff that relays see, or this goes across the protocol, into an envelope and a payload, okay? So the payload is the video content, the audio content, whatever the media is. It may be encrypted, it may be DRM protected, it may be anything, or it may be totally unencrypted as well. But the key point is the relay can't depend on being able to look into the payload to see it. The envelope data, on the other hand, is really what this presentation is going to mostly be about. And this is the stuff, what is it that the relay needs to see? In an IP sense, like, you need to see your source and destination IP addresses, or a router can't route it. It's like that type of stuff. Obviously, our goal here will be to put the minimal stuff we can in the envelope for a lot of reasons, and do it. So that's just the terminology I'm using to define those two different chunks of sort of data that we need to deal with. So I don't want to delve deeply into what all the drafts do on this, but Warpad, an ID for a stream and some delivery priority stuff, perhaps dependency list. The Defoe draft had, similar set of stuff with a bunch more data that might help it work in a 5G context. Quicker had some sort of different things with, time to live or timestamps and discardable. But the exact details of all those drafts don't really matter. What matters is we start figuring out what our use cases are that drive the need for chunks of data that go into this envelope and what they are. And I'm going to talk about a couple of those in the slides coming up. I can't see if anyone's on the queue, so warn me.
You will see it up in the right-hand corner.
Oh, okay, cool.
Yeah,
I will see it then. So probably the biggest one, and we were already talking about that earlier, is this priority and delivery order type stuff. And all of the proposals have some form of idea that there's sort of a base priority related to the draft, and I'm struggling because different you know, Luke said terminology is hard here. Different drafts have done this a little bit different ways, but there is definitely a concept in all the drafts that if your application business logic feels that audio is more important than a video, there's a way of indicating in there that relays should forward audio before they should bother forwarding video for the same thing. And similarly, different types of video might matter differently. I was thinking about, you know, your 360p video is more important than an adaptation layer that it goes 720p on top of it. But, you know, as Luke pointed out too, if you have advertising video and non-advertising video, your business application may say, business logic may be that the ads are more important, right? So there's some application layer things at that type of idea. And then there's this stuff that has to do with sort of delivery order, some sort of numeric counter of these things. And that was a lot of what Luke was talking about and helping try and motivate and explain in his draft of, look, if you have some data that depends, if you have a P frame that depends on an I frame, but you can't deliver the I frame, there's really no point in delivering the P frame. That data is useless. There's nothing you can do with it. So there's some sort of, you know, sense of a natural ordering that way. There's also data that is so old it is useless. That's really what we mean by real time when we talk about real time video, right? Is there's stuff that's too old to be of any use. And so the warp drafts, you know, took the approach of the newest thing was always most important in this sort of context. That might be completely right or mostly right with some fine print and hand waving, and I'm sure the working group will dig into that deeper as we hit that. But we need some way of sort of understanding the decoder order of these types of things. Of what's needed at the other end and what makes sense to be delivered in that. So this is similar to, you know, in RTP you had sequence numbers. We have different stream or segment IDs, whatever we call streams, segments, layers, fragments. We have, you know, that type of way. We need some way of ordering that, and we need to decide how that ordering number relates to the priority of it being sent within the broader priority of the audio is more important than video. So I see these as two different things. I mean, both conceptually, everybody agrees there's two different things and we need both of them here. How they get mapped to bits may be one thing, two things. We can sort of debate that later, but I think that the key thing for us is to understand what it is we want the protocol to deliver, and that we want relays to be able to look at this type of information and start to deal with it as they forwarded something on. And remember, if a video stream was sent up, you know, in multiple renditions, one at 1 megabit and one at 2 megabits, and there's a relay that has access to both of those, we will be doing the normal thing of clients, you know, connecting and asking for the one that has the right bandwidth for what they need. None of that's taking away from that, but you still need to understand what's priority to deliver inside of that. No questions. Okay. So this is actually what I think is the most thing to land in the envelope data, actually. Dependency indication. So this gets to how explicit we want to get about this. And I think this would be a great thing to get some feedback from the working group on today as some ideas. So one way that we could do, and one of the warp drafts had a proposal for this, is, I mean, we could have a dependency list where we could say these chunks of data, segments of data, depend on these other chunks, like by named ID, and that relays and things could look at that and figure out what to do with them. Some of the other drafts, Quicker being one of them, use the idea that there just be like a priority, like, you know, audio's priority 1, you know, 360p is priority 2, 720p is priority 3, and that the application would pick those priorities, but with a small number set of numeric priorities, they would be able to deliver, you know, get the end effect they wanted on the relays. So one of the questions that we'll have to figure out from the working group is, should we have a dependency, an explicit dependency list, or can we get away with just having this sort of, you know, general priority idea to be able to do this in the relays? And what do we need to do there? That's sort of one of the areas. Caching is another area where the quicker drafts did assume sort of this, but we could or could not have this. So this is not very important on the ingress side. This is all about the distribution side where it's probably more important. And on that side, you come to the idea of, is it useful for one of the relays to have a short-term amount of media data that's there available to it? And this can help deal with tasks like when a client first joins, there's already the previous iframe is there and cached, and they can get the previous iframe instead of waiting for the next iframe to be transmitted and sent into the system. It could be pushed a little bit farther. You know, some interactive applications, Skype long ago even sort of did it, but you know, various applications playing with the idea of, well, if you missed some packets, you could pause the stream temporarily, roll back in time, and then play quickly forward. You know, those types of ideas where you can catch up. We could or could not support those. This could be something that the protocol, if we did this at all, I'm sure it's something that would be optional for the relays to ever cache more than 0 bytes of data. But you know, caching and whether we want to deal with that is one of the issues that we'll have to touch on that side. It could be done as completely an extension draft, right? It's those types of things. Let's see, security and privacy. So as I said at the beginning, the relays can only read the envelope data. And other network elements can't, you know, routers along the way. This is all inside a normal quick TLS connection between the consumers or producers and the relays. Okay, so this doesn't change quick TLS in any way. Like everything's encrypted over the network with quick TLS exactly as you would expect. And exactly like today's CDNs as well. On a classic CDN today, yeah, every connection might be encrypted with HTTPS, and the media that's being moved around inside of that connection, you know, maybe DRM encrypted, right? So I think that we're trying to very much follow that same model that's worked in that space and allow for this. Now, one of the things about this that we do need to sort of, you know, handle is like, do we need techniques for dealing with integrity of what happens of the envelope data? My view is that there's no, actually, let me go to the next slide on this one. No, sorry, I took this slide out. I'll go back one. Okay, so my view is that the relays shouldn't ever change envelope information. That they can read it, but they shouldn't change it. And if you were on a system that chose to use MLS group keying, then you could get away with actually providing real integrity protection of the envelope data at the ends. It's not like the relays in the middle would do the computational work to check it probably, but they could. So Spencer, you had some questions on the list, and I see you on the queue now. Does this answer my view anyway on where we should go on these key items?
Spencer Dawkins, too long don't read or don't listen is yes. But the thing to me that seemed helpful for me to be asking about this is what a useful name for what are called relays now would be that would be clearer and probably just a functionality kind of thing. We talked recently about me asking, so is this a general purpose relay? I think not. Or if it's not, what kind of a relay is it? And I think after seeing that part of the discussion in your slides, which are incredibly helpful to me, thank you. But I think that what I think you were saying was that this would be a relay that relayed whatever rush warp is. It ends up being called. Would you agree with that?
So I view these relays as 100% tied to the protocol that's coming out of this working group to relay the data, right, the media, right, that this working group's done. That's what's tied. Now, That makes it sound like a specialized relay. It's only a relay for the MOQ protocol. However, given the MOQ protocol is meant for moving any media, and nearly anything you ever want to move can be considered media in some form or another, it is an incredibly general thing. So what this working group is really talking about building from day one, whether you think about it or not, as soon as you talk about moving media over quick, or media over anything, in some real-time way, we are talking about building a better set of ways to move real-time data around the network, and it will turn out to be incredibly generalized if we get this right.
Right. Okay. Right. Like I say, I think my biggest thing on being able to explain to people what the scope is number one, figuring out what the name of Warp Rush is, so that you can say we relay. Among whatever else we do, we relay that.
Yeah.
So from a chair's perspective, thank you very much for the intervention. But I'm going to ask that we not actually spend a lot of time talking about names, because
right.
What I think you were asking for is a description of relay functionality. That's absolutely cool. But we don't want to spend a lot of time on names because it's an enormous bike shed. And I will note that the queue ballooned the minute you said names to 7 additional people who no doubt have great ideas of their favorite name. If you're in the queue to talk about the name, please get out of the queue. If you're in it to talk about relay functionality, welcome. We look forward to your insights, but we can keep talking about this as the MOQ protocol, good name coming future, and the MOQ relay. Functionality to be discussed, no name discussion, please.
Right, thank you.
Just in terms of processing the queue, I think, Colin, you only have one more slide after this, is that right?
Sure.
Do you want to just try to finish it up and then take all the questions?
Please do that.
Okay. So now I have to get back to where I can actually do that. Okay, one more slide here. So this slide undersells the problem here, but when the MOQ client connects over the MOQ protocol to the MOQ relay, we need some idea of what it is that is used to authenticate and authorize and allow the relay to decide that it is going to be willing to forward this traffic in a meaningful way. Okay, and basically, initially what I had written on this slide when I first started was that, there'll be an authorization token and some form. And really, I think that we come around to that, there's an authorization token that the application got, that the consumer or producer got in some out-of-bound way, that it allowed it to pass it to the relays. It probably also found in the same out-of-bound way what relays it might want to use. And that the relay said that. Now that is such a fluffy hand wave to the whole problem. It's completely useless, okay? So I recognize that, but I think we're going to end up something along those lines. Now, option 2, which was, I forget who proposed that to the list right now. I'm just blanking. I apologize to you, but it was Will. So, Will said, hey, look, actually we've had this problem lots. We've thought about it lots in existing CDNs, and there's some really good approaches to steal from here that have a bunch of advantages over what was being discussed. And so I'm, as an individual, very much in favor of going down this sort of, number 2 type option, where we take the same type of ideas of what has worked to be very scalable in existing today HTTP CDNs and apply it to these MOQ CDNs. So that was really my last slide, and so we can talk a little bit more about that Wednesday. So let's go back to the question queue.
Okay, before we do, I just want to do a time check for people. It is 10:45. We close at 11:30, and we have a pretty hard stop because they need to set the room for the next host talk. So please make your interventions pithy and be ready to have quick responses. The first is Emad.
Nice presentation. So quick question regarding the last slide. So I love you said minimize the information the envelope should have for the relay, but should not keep it as is, because server developers love to have everything. If we keep it as is, it will be vague. So I think we should include what information should be there, what information should not be there.
+1, okay.
Hi, Phil Humbaker. Yeah, it's implicit in what you were saying in the intro, but I don't think we need to be able to have a relay that is doing a meet echo function that is completely unaware of any of the content that is being gated. So, you know, I want to do meet echo, but without the relay being an endpoint. So I think if we could add that to the use cases, it would be useful in making sure that we keep enough information to make that possible.
Okay, let me paraphrase what you're saying here and make it a little bit tighter than what you said, but I agree with you. So obviously, if we're doing an application like Meet Echo, we can definitely make the relays not have access to any of the media content for sure and be used to help scale out something like Meet Echo. But Meet Echo also probably requires an SFU somewhere, and these relays do not 100% do the functionality of an SFU. You'll still need an SFU in some sense, which also can be end-to-end encrypted. But yeah, okay. So
yeah,
that works for you?
Yeah, there's got to be enough metadata to allow the switching to happen.
Got it.
Yeah. The other thing on the authentication piece, if I've got a large fan out and I've got Fred who's been creating data and we're using Mac or whatever to authenticate, I don't want Fred to have a million shared secrets with all the endpoints. I don't want one endpoint being able to impersonate Fred. So the logical implication of that is the relay is going to, Fred is going to authenticate to the relay, and the relay is then going to re-authenticate to each endpoint in that scenario.
Okay, I think that is a hot and deep area. You're not wrong, of course, and I think that'll be a great topic for the working group after we get past some of the easier stuff. But we're like, but you're totally right. But I mean, people aren't even ready to. It's going to explode their heads, Phil.
Hello, Robin Marks Akamai. I've seen Luke and you talking about priorities for streams and dependencies between streams, and not doing it just at the origin, but also in between. And this starts to smell a lot like HTTP2 dependency tree, which is a notoriously bad idea that we're still suffering from today, especially people like me. I think this is too complex for the new extensible priorities that we have in HTTP3. But what I mainly want to say is keep it simple.
Great feedback. Yes, I will. I'm on the same page.
Mozinati, so quickly on the dependencies, I think if you look at what we do in RTP and a lot of assumptions is that sequence numbers are always implicit dependencies on the things before them. The difference here is that now we're talking about independent quick streams, and is there going to be some sort of signaling of the dependencies across those quick streams? Because they may not truly be independent. They may be in the SVC case, different layers in each of the streams. Or for various different reasons, you may have different encodings that split things up across streams, and you want to be able to describe the dependencies of those streams. I think it's pretty simple to have a simple and flexible way to describe those without too much complexity. We have the frameworking draft. We have 81 dependency descriptors. You're talking about, like a simple 1 byte thing that gives you almost everything you need to know. But within a stream, I think it's just simple to keep the basic rule. Everything is in sequence. What came now depends on everything that came before in that stream. That's a simple assumption to start out with. And then secondly, I'd like to understand from the Meta and Twitch folks, you must already have some relays. I assume they're just your own built relays. If you had to replace those with Akamai, Cloudflare, Fastly, whatever, what would you do differently, or what would you have to encode in the protocol to work with a third party? I think that's an important thing to get out of the protocol, is for people who wanted to have vendor infrastructure, it's not their own. What would we need in the protocol to enable that?
Magnus Westlund. It's interesting around this envelope information and the security. If you're actually going to sign, etc., it needs to be stable across the whole system, which has been a classical case, which doesn't work in RTP because you have leg by leg, or basically endpoint to endpoint dependent signaling. So you're going to have interesting, actually ensure that you have a global namespace for identification, etc., of this type of information. So.
Yeah, 100% agree, and that's part of why MLS is in the charter.
Piezo Hanlon. I was just going back to the ABR stuff in that you kind of have this very fine-grained kind of behavior happening at the sort of like per stream representation level, but then the ABR sitting in some kind of browser sandbox, kind of trying to measure throughput on a JavaScript sort of API and making an ABR decision there. There seems to be quite a big disconnect between the amount of information that's kind of, you've got this very fine-grained stuff happening at per rep, but then switching reps, you've got sort of crappy information that sort of you're getting kind of quite messy, like timing and data arrival stuff. I mean, the streams API, for example, doesn't even give you a timestamp when you get a callback. So trying to measure that. I'm thinking sort of signals or something like that from relays that could then help that. But
cool idea to get some signals from the relay to help that. I hadn't thought about that. I had thought a lot about, given this is all running in user space, the quick, and all of this is running in user space in the application, I was hoping that this working group at some point would be sending some requests over to the quick working group to expose some API information that we can use. For example, the current, bitrate estimate that the quick layer has would be really useful for.
Yeah, I mean, that's a constant kind of thing. NetInfo API has been sort of like in and out of, like, it's not really kind of flying anywhere apart from Chrome. And so that kind of thing is tricky, it seems.
Yeah, but there's such a huge advantage to having a lower level feedback on the information. Allows you to react much quicker, which allows you to deliver a much better end user experience. And I think that that's one of the things that we need to optimize as a group is,
yeah.
This information is all in the same computer, but our layer stacking has caused us to not have the information we need that would allow us to deliver a much better end user experience. That's nuts.
Yeah, it's true. Although sometimes in some ways there is actually information that's at the server, at the relay that the client doesn't actually have, like the kind of effectively the Seawind. I had a draft transport info that basically tried to do that. That we've got some stuff in CMSD that potentially does something like that. But anyway.
So we should drive all of that discussion forward. It's a great discussion. I think very important. Thank you.
Okay, so we started out with 12. We've had 7 people at the mic, and now we have 10. So I would like to say we're going to close the queue very quickly here. So if you think you're going to have comments on this, probably go ahead and get in the queue.
Will?
It's Pierre. Will next.
Yeah, thank you. Will Nolakamai. I'll be quick. I agree with the vast majority of the points presented here. I think Mark has the luxury of looking back at 12 years of Dash and HLS, which used relays in a very similar context, and look at what should we have added to those formats in the very beginning that would really help with operations today. And there's 2 aspects that are not the attractive ones we like to talk about. One is request tracing, being able to debug as soon as you're going through components owned by different people in multi-CDNs. How do you know where a problem's occurring? So request tracing, tracking where it went, and then also logging. If you ask people today, what does a quick or web transport log look like? You're going to get 50 different answers. So we might start thinking about standardizing that so that if you are collecting logs from 5 different CDNs operating your relays, that they're going to be consistent.
Thank you. I love it. And I hope whoever's taking minutes got all of that.
Corey. Since he's our minute taker, you can ask him whether he got all of that.
I saw from his face that he was doing his best, but not.
I tried. Yeah, Corey first. I was just going to say, we're talking about the intermediary being a relay. There's probably some interaction with the network that might be possible. Can we take that to transport area, TSVWG or something, and talk about that completely separate to talking about the relay? But if you're exposing things in the relay, then maybe something to the network might turn out to be the right thing to do.
100% agree. Mo touched on that earlier. And you're the person that's helped us do that all in the past with every other media protocol we've done. I hope we can get you involved again.
Hey, Stefan Wenger, regarding the dependency indication question you posed. This is very, very tricky. The one reason why previous dependency indications in the video coding standards, NH264 had 2 bits for some priority thing, never worked out was because there was no defined behavior, what to do with these two things, and with these two bits, and therefore people set them any way they wished, and no one cared about them at the end, even if the encoder choose to do that. So this particular problem here for this protocol is even harder, because we now have different media types, some of which we don't even fully understand. And the lifetime of this protocol is probably larger than the full understanding of what you need, say, for haptics type of priorities or whatever, right? So the my recommendation there is to have a single one-dimensional number, not any complex dependency graphs with B-frames or whatnot, but a single number with a limited range and a defined behavior of how a gateway reacts to this number. And then the encoders and the sending mechanisms can figure out how to set this accordingly. Thank you.
Thank you. That sounds like really good advice for us.
Luke from Twitch. I was just up there. But my day job is I work on the CDN team. So I've thought about this quite a bit. One thing that I'm grappling with internally is just how successful HTTP and HTTP CDNs have been because they're stateless. The idea being is we get millions of viewers across thousands of streams, and we don't care. Like you don't actually need to keep track of them. It just kind of funnels all the way through. So I'd like to have more thought about how much state do we really need in the system? How much state do we need for media over quick? And how much can we defer? Like, for example, slide 1, the origin is the final decision maker, probably wouldn't work at scale for this point. That's one thing I want people to think about.
So look, before we walk away, totally agree. But I want people to, I constantly have people tell me it's stateless. And I'm like, oh, well, how do I request something? They're like, oh, you give us the URI, and from the URI, we know, given the state we store, what to deliver to you. I mean, I mean, stateless is a wonderfully bizarre term to use in the context of a file server, right? So it is stateless, but I think that the point I 100% agree with you on is we have to really carefully think about what the state is. There's TLS state, there's all kinds of state in those servers. We need to really think about the state and how we make high reliability, cheap, scalable systems, you know, how we engineer that and get it.
We decide the state at the start of the broadcast when somebody joins. And then we just encode that in the URL, and from that point forward, it just follows a fixed path, more or less. So it's pretty simple.
Yeah, exactly. Yeah. Which sounds like we could do the same thing here. Yeah.
Han from Huawei, can you go back one slide to the security?
Sure. Give me just a second here. There we go.
Yeah, I think the NASA point that the quick stream is 1-to-1. I think there is a draft about multicast quick. It make quick become the 1-to-n. So if we use that, we may be able to do the end-to-end quick. And for the metadata, maybe we can put it in the outside of the quick. Of course, you need to encrypt it. Yeah.
Thank you for correcting me then. I was unaware of this multicast quick work. I'd love to read more about it. And it seems like this might be a prime use case for it if it all works. This is my mistake on this slide, and I will update.
Yeah, and I think doing the end-to-end quick may enable very light CDN kind of, because really doesn't have to decrypt all the quick packet. It only need to look at the metadata. It's very small amount of computation, maybe.
Interesting. Okay. Can you send a link to that work to maybe the chat room or something? Or whatever.
Or even the mailing list.
Yeah, the mailing list. What?
Randall Jessup, Mozilla. Plus one to what Stephen Wenger was saying. I was going to say something similar. I think that what this does is it helps push the complexity on the choice of the priorities and so on out to the application, which will allow for future changes and improvements in what's going to happen there. Whether it actually comes down to a single number or not, I wouldn't want to decide now, but I do think we want to simplify and tightly define what the relays are going to operate on, so that then you can innovate at the edges.
Thanks, Randall. 100% agree. That makes sense to me. And all the input from you and others here has really convinced me which way direction I want to go on this. So that's good.
Hello, Ian Sweat, Google. As a person who spent a ton of time trying to kill HTTP2 priorities, I actually would make an opposite argument here and say that I don't think we should immediately assume because HTTP2 priority was like a complete dumpster fire, that it actually applies. And my argument is as follows. So one is, in HTTP2, the client is attempting to guess what the correct prioritization scheme is. Here, the producer of the content knows the structure of the GOP, and it understands the frame dependency. There is no, it's unambiguous. It's absolutely like, it knows it or not. Another thing is, we had things like reprioritization. There's no need for reprioritization. There's no need to like reparent things and do all the things that are very complex. And for example, like in HTTP2, when you cancel the stream, everything under it got like reparented automatically. Here, I would argue either you don't allow that at all, or if you do allow it, you just basically like kibosh the whole stream. So you, because they're all dependencies, you can just like kill that entire tree. You don't need to wait and like trying to reparent it and all those things. So because we understand the use case, I think it's a completely tractable problem to use trees. However, I also will say, I'm not sure it actually provides a huge amount of value over like the stream per GOP approach. And so I think that's something for the working group to decide, is whether the marginal complexity is actually worth it. But I don't think it's, I think it's a completely different situation from HTTP2 because the problem is different. Who's sending the information is different. Like again, a huge problem with HTTP2 was Firefox had a prioritization scheme that it kind of like invented based on like looking at the spec and trying to figure out how to use it. But like there was no right answer. Like everyone did something different on the client side. None of them were right. And most of them didn't work particularly well. Here, we have a fairly authoritative answer on what the right prioritization is, at least within a GOP. So those are my thoughts. Thanks.
Thank you.
A quick question. It showed that you were trying to request the screen. Did you actually have something you meant to be showing, or was that just a...
That was a fat finger.
Okay, no worries. Thanks.
So Cisco, thanks, Cullen, for bringing everyone on the same page on what relay on some of the requirements we need here. A couple of points. I agree on the state argument that you and Luke made. We need to make sure we keep the state as minimal as possible, as it helps for the distribution. Anything over than that, we need to kind of discuss in the group and see if we really need it or not. Second thing, I want to echo what Randall and Stephen said on the dependency or prioritization scheme. Whatever we do, relays should not be made to aware of each and every video codec and dependencies they bring in. They should be as media agnostic as possible, but should be able to give minimal information to make a forwarding or drop decision. And if you can come up with something that fits that requirement, that would be easy to build scalable relays. Last part is that I don't see you talking about how the clients would pre-warn the relays in case where they wanted multiple qualities so that they can easily switch between different qualities. Maybe you talked about it but missed, but something that we need to keep in mind on how can relays kind of subscribe to various qualities so that whenever client, because of water network conditions, goes to different qualities, it would be quick rather than going through all the way the chain of relays to get the qualities that needed at some point. Thanks.
Right. Yeah, I carefully just avoided in my slides the whole topic of sort of naming or that evil subscribe word or anything like that. But I mean, one way or another, we will need to be able, like all of these things, imagine that we'll be able to, you know, something could express, it could get a consumer could get a 4K stream, and if it could realize they didn't have the bandwidth and switch down to a 1K, you know, a 720p stream or something. I mean, clearly we need to deal with that in the working group. I just didn't feel we had the right drafts and agreements in place to really hit that problem yet. So we'll need to figure out that type of stuff down the road a little bit. But I just sort of chose for the limited time to kick that can down the road a little bit. Peter.
On the topic of congestion control, there's nothing stopping a native or mobile app that's using a quick library from getting to information about the congestion control. However, for a web client, which I assume you will want some web clients that do ingress into a relay, you do need an API that can expose information. Luckily, we are working on that in the web transport working group in the W3C. So if there are specific things you need beyond what we're already doing there, that might be a good thing to ask for. Similarly, on priorities, I think we've mostly been talking about priorities that are sent to the relay, but there's also the question of the local prioritization of streams at the client, and that also relates to a web client API, and that's also a topic in discussion in the web transport W3C working group. So if there are things that need to be requested of another working group, it might be the W3C web transport working group. Lastly, oh, I forgot. I'm sorry. Hold on. Let me see if I can remember. Nope, it's gone.
So Peter, before you get to your last thing, just 100% agree what you said. And I might ask you if you could just send a little bit of an email to the list here. I mean, I know you're deeply involved with all that stuff. You could just send a little email to the list with pointers to people where they might be able to read a little bit more about what's going on there. I think that would be, I mean, this group's going to have a synergy with, transport, web transport, quick. And so getting people aware
Sure.
of that would be awesome. Yeah.
I could do that. Oh, I did remember the third thing. The third thing is basically everybody wants implementations of Quick that have a real-time friendly congestion control algorithm, and I haven't really seen one yet. And I think that in order to write one, for example, if I were to port the typical WebRTC one called GoogCC over to Quick, it would require some more timestamp for information in the feedback messages, and that I've seen 2 drafts for that, proposals for adding that as a Quick extension, but I don't think either one has, progressed a lot. So that might be another thing that might be a request to see one of those progress.
So I 100% agree with that. I think we do need to move that along over time for this group to be successful. I don't think it can be done in this group. I think we probably need to take that somewhere else. But the people here can, probably are the same people that need to do it somewhere else and explain what our needs and why the current BBR v2 doesn't quite work, but what could be, or whatever it is that we're going to decide to do to have better congestion control for our applications. I do think this application I do think that Media over Quick will work reasonably well with today's congestion control, but it could work much better with slight changes to the congestion control that we should try and get from the appropriate working groups or something. So that's another thing that we should poke on moving forward. 100% agree. And just maybe now that this is really moving and is real, it's an incentive for the people who had those drafts to resurrect them and get that going again. Next.
Sam Hurst, BBC R&D. So it's not specifically a comment on your presentation, which was great, by the way, but more something which keeps coming up in other comments that people have been making. And I wanted to make sure it got captured somewhere. We need to make sure that we don't end up focusing on frames as a unit. So I love the idea of Warp being able to arbitrarily chop up GOPS and have different numbers of frames within one stream. We've got to be careful because when you're thinking about audio, what's the application data unit there? And is that a sample? And if we end up just having a new sample per stream, we're going to use up streams like there's no tomorrow. And there's also then other media types, like what do we do with subtitles? What do we do with haptics, which is a new one coming through? We just need to make sure that we don't specify that there's one for every ADU and give the ability to have more than one of those. And then how do we synchronize them? But that's an entirely different topic.
Great point, 100% agree, and we tend to over-rotate on video and forget about other things, but yeah.
Hi, Jonathan Lennox. I mean, something that I was thinking about when the Medico case was mentioned, and generally like the case of if you're trying to, essentially live stream a conference, is the case where we will have cases where we have media from independent media sources. We probably want to send those over the same MOQ connection for prioritization reasons, and we need to make sure we think about that both for prioritization and for the protocol to figure out how that works. And I just want to make sure that's, on everybody's mind as they develop this.
Yeah, and I think that comes up, as you said, in the conferencing scenarios, but it also comes up in the ad insertion scenarios. But yeah, we need to keep that in mind. I think we have an empty queue. Thank you, everyone. Much appreciated for all the people showing up here today and moving this along. And I will pass it back to the chairs for whatever happens next.
Thank you very much. And thanks everybody who was at the mic line or commenting in the chat. I will say if we were seeing this level of engagement on the mailing list, we would be having a weekly interim calls. So please do bring these same issues up now that we've kicked off the working group on the mailing list or in the appropriate repos, and we can go from there. Get the chair slides back up so we can go on to the next thing. All right, so before we get to AOB, which will possibly include Spencer's presentation, which he gave us as a backup, a quick question on possible interim, and I think we can run this as a poll. I'm going to try and do that in a second. We think there's a lot that's happened here today and a lot of discussion that have been kicked off at the previous interim, and so we'd like to think about having maybe an in-person interim over a couple of days. What Alan and I have been discussing is late January of 2023. That's next year, surprisingly, and the U.S. West Coast. There are a couple of people already in queue. So you have clarifying questions or comments before we run the poll? Okay, please go up, Spencer. Anything we would do would, of course, be hybrid, not only in person. But Spencer, you had a clarifying. Mo, did you have a clarifying question?
I don't know if you can still clarify. So, Mozinati, I was going to ask, in the prior interim, we identified two major points of discussion that we wanted to try to cover either in person this week or, in the near term. And that was the congestion control and prioritization aspects, and then media formats. We haven't started the media formats discussion. Is that going to be a focus of this interim, or do we want to start that just on list and not
so I think we touched on it a little bit today when people were reminding us, including Stefan and others, that we need to consider media formats beyond video and not only video. But I definitely agree that we need to have deeper discussions of those on audio, video, and potentially upcoming. It might or might not be at this interim. If we agree on an interim, then we'll start the agenda bashing for that.
So you don't have a specific agenda for this interim yet?
No, we think there's plenty to talk about, so it will be list discussion to hash out who can be there in person and in particular which topics people will have drafts or similar for. Spencer.
Spencer Dawkins. I've made this comment in chat, but I don't know that the chairs have been able to keep up with everything that's happened in chat. You might want to also poll on how many interim meetings, and I was thinking virtual interims between now and Yokohama. And I had a couple of thoughts about possible topics, and neither one of those was the one Mo suggested. So you all are talking about a in-person interim. Yes, please, that would be lovely, but I would suggest that you wait for the working group to make progress on the mailing list as opposed to in Slack or something like that before you decide that we only need one. I could see multiple reasons why you might need 2 or 3, but let's ignore that for now.
Okay, I have Suhas and Cullen behind you in line, and then we're going to run the poll. I think we can at least figure out whether we want 0 or 1, and if it grows beyond 1, we can continue that discussion. But Suhas.
Just a clarifying thought here. Luke's presentation had some of the next things that we want to do. That might be a starting list. We can think of the possible topics, and also depending upon the topic, we might get a different audience and we need to make sure that we have the right audience in the meeting. If not, it will not be useful. Thanks.
Colin.
Love to have one, but I think the really important thing is late January is incredibly close when you consider the holidays and everything. So I think we should nail down the date soon if we're going to do this, like before the end of November type soon.
That's partly why we want to have the poll run today. Okay, so the way I have put this is if we have an in-person interim in late January 2023, please assume I said US West Coast here because apparently I forgot to type it. Can you attend either in person or virtually in that time zone? So please understand that any place we have this, there will be support for remote attendees, but that time zone, late January. Raise your hand now if you can. Do not raise your hand if you are not available there, and we will see how it goes. So far, only about a third of the people in this room have either raised their hand or clicked do not raise hand. So please go ahead and do one or the other as quickly as you can. Thank you. There's someone in the queue. Okay, the numbers are starting to change pretty slowly. I'm going to close this off in 30 seconds. Okay, so certainly quite a few people were able to do it. The raise hands were 52, the do not raise hands 10. That's a significant number. So what we'll do is go ahead and come up with a concrete suggestion on the list. Alan and I have the token to do that. It looked like there was somebody in the queue, but who may have since dropped. Yeah, he dropped. Okay. So we do have a couple of minutes there, and there was a update on the mock use cases and requirements doc. Spencer, do you want to do a quick run through that?
So I'm Spencer Dawkins. I want to call people's attention to the picture that's on the cover slide, maybe more than anything else. You know, the idea that use cases would interact with requirements and that those would drive protocol specifications. If that's a shock to anybody, please tell us now. Next slide, please. So what we said we were going to do was work on basically dragging out a lot of stuff that was in the individual draft for use cases and requirements that would not belong there. Some of them were talking about things that were not in the approved charter, and some of them were just history and observations and opinions. And so what we did was update the use cases section. Well, we updated the draft this way and went to update update the use cases to reflect working group discussion on the slide 3 questions from the October interim. There wasn't actually any discussion of those questions from the virtual interim. So we submitted -03 and for extra credit, did a proposal of initial structure of the requirements section based on our understanding of the implicit requirements in their approved charter, which was based on Suhas's understanding. Next slide, please. So yeah, that. So, and like I say, added a little introductory text in each subsection of the requirement section. Next slide, please. So this is, I did talk with James, my co-author, since we got the comments from Cullen that appeared on the mailing list. Thank you for those, Cullen. So thinking we would do a -04 revision before requesting that the chairs would adopt anything. And then basically after something that the working group could adopt, we would be drilling down to the next level of detail in use cases and next level of structure in the requirement section. Next slide, please. So I did have some questions there, like I say, which we will follow up on the mock mailing list for all of these. We were trying to categorize the live media, gaming, and video conferencing use cases, and then think about that some more. Again, we'll follow up on the mock mailing list anyway. And once we get to that point, talk about any additional use cases that would need to use a simple low latency media delivery solution for ingest and distribution. As we mentioned earlier, those are out there, but the ones we would need to know about is use cases that rely on capabilities we have not previously identified. Next slide. And so we had basically a high-level structure from our understanding of Zuhas's high-level structure from the interim meeting, and which I really appreciate. And they basically agree on a starting line for the requirements, and then proceed in the usual issue PR merge way on GitHub. Is that my last slide? I'm trying to remember. No, we are not. Like I said, Cullen sent comments that were helpful enough to where we would need to, James and I both agreed we need to do a -04 before asking people to look at it seriously. And we're committed to do that in the relatively near term. Any other thoughts? Okay, that's everything I know. Thank you.
Thank you very much, Spencer. Note that we will not be waiting to an interim meeting before issuing a call for adoption on this. Once we've gotten the mailing list discussion to a point where we feel like the working group is ready, we'll issue the call for adoption on the list. So please do continue to join us on the list so that you can do that. We have reached the 11:24 mark, and the question is there anything else for the good of the order?
David was in the queue, but then fell out. But you can go ahead.
Oh, sorry. Thanks. David Skenazy, process enthusiast, apparently. No, just I wanted to provide a small suggestion to the chairs because this reminds me of when we did a requirements doc in Mask, and it was helpful, but we ended up not publishing it, which was quite disappointing for some of the folks working on it. So I would just say make that clear at the beginning, whether or not you plan to just have it and not publish it, or if you're going to publish it as an RFC. Both are valid options, but I would make that clear during the adoption call so no one's surprised.
Thank you for that point. Certainly, as people are commenting on it in the run up to adoption, you can consider that, but and make comments on it then, even in advance. Back to the previous question, is there anything else for the good of the order?
There was someone else in the queue, but they just dropped out.
Okay. Thank you all for all of the great conversation, both in the lines, remotely, and on the chat today. We look forward to seeing you on the list. Thanks again.